Good morning. Welcome back to 13th lecture on remote sensing and GIS application. Till now we completed the first unit. Introduction remote sensing was already completed. Now we are entering to the second unit, image analysis. In second unit image analysis, we have 8 topics: introduction, elements of visual interpretation, digital image processing, image pre-processing, image enhancement, image classification. That classifications are two types: supervised and unsupervised classification. First, today we are going to discuss about introduction. Before going to discuss about the introduction, first in first unit what we have studied, basically what we studied. So how the satellite image is creating in processing station. Before produce the satellite imagery, first the satellite sends the pulses to the target and reflected the radiation is recorded by the target. Then the sensor sends the processing station. Then the processing station image processing, after apply some image processing techniques, then the satellite imagery is produced. So what the techniques are they are using for producing the satellite imagery? In this unit, what you are studied, what we are learning, before going to produce a satellite imagery, they are using some image processing techniques to produce the satellite imagery. So how the raw data, till now the raw data is get the processing station, then that raw data converted to satellite, how the raw data converted to satellite imagery, then how to interpret the features on the satellite imagery. In this chapter we will study interpretation, image techniques, digital imaging processing techniques, and what is the pre-processing, enhancement, classification. These are mainly important in this unit. First one, today we are going to discuss about introduction. Image processing is the method to perform some operations on image in order to get enhanced image to extract some useful information. So whenever you extract the information from the satellite imagery, just you should apply some processing techniques, some operations on the satellite imagery. Then only you will easily extract the useful information from it. It is a type of signal processing in which input is an image and output may be image or characteristics or features associated with that image. You have two types. One is input, then we will get the output. So input, we will apply some signal processing techniques to that data, then only output we will get the features. That feature may be characteristics or features are associated with some other features. So entirely we are studying image processing techniques, and after getting the satellite image, how to extract the information from the satellite image. This is the main concept of, main motto of this chapter. So image processing basically including the following 3 steps. So how to do the image processing? By using three steps they are doing the image processing. First one, in processing station we will get raw data. So first what should you do? You take the raw data from the processing station, then you should do importing. Second one, after completion of importing process, then you can go to analysis and manipulation the image. Manipulation and analysis. Third one, output, we will get the results as a output. So image processing 3 steps. One is importing the data and analyzing the data, manipulation of the data, and output, in which result can be altered image are reported that is based on the image analysis. These three steps are very important to processing of image. Then, interpretation and analysis of remote sensing imagery involve the identification or measurement of various targets in an image in order to extract the useful information about them. What is interpretation? Interpretation is nothing but examining the identifying the features on the image by using by your human eye. So first we should identify the image. We should identify the features on the image. Then after identifying the feature, then you can measure that feature. But by using various techniques, you should measure that feature. So first point. Second point, target in remote sensing imagery may be any future object which can be observed in image and have the following characteristics. What should you do? Whenever you take the satellite image with your processing station, just whenever you are seeing with your human eye, so many features also appeared in the satellite image. So many features means, see here, so many features also appeared. Line feature means road network, railway network, buildings, trees, forest, river network, water body, streets, small huts. So many features also appeared. What should you do? First you should divide three parts. If when that is, one is polygon feature, second one is point feature, third one line feature. Whenever you are before going to interpret the satellite imagery, first you should remember you don't entire features you can classify into three types of features. One is point feature, second one is polygon feature, third one is line feature. So that is the rules. You should follow these two rules whenever you interpret the satellite imagery. First point is targets may be point, line or area feature. This means that they can have any form, from bus in a parking lot or plane on a runway or to a bridge or roadway to a large expanse of water or field. So how they classified? Based on the feature of the shape, based on the shape of the feature. If the runway is straight, then that is the line feature. Water body is a round shape, that is the polygon feature. Point is nothing but a small huts, small point like features, that is point feature. So you can classify into three type of features entire satellite imagery: point, line, polygon. Second one, the target must be distinguishable. It must contrast with the other features around it in the image. So the target, if you want to distinguish two features on the satellite imagery, just you can improve the contrast of the image. Whenever you improve the contrast means enhancement. Whenever you can improve the enhancement of the image, then only you can easily separable the objects in the satellite image. See, if you observe here three images. First image, I take the zoom from the satellite imagery. This is polygon feature. How you can say polygon feature? Polygon feature means this is a rounded shape. A round shape feature is nothing but a polygon feature. Just you see, by using Rs&Gis image, Rs&Gis software, they are doing polygon. This cyan color one line is there. This is the polygon feature. So any satellite imagery, you can identify three features: polygon feature, line feature, and this is the important point. If it's right side, if you observe this image, this is the line feature. This is runway. Runway means the straight line feature. That's why this is the line feature. You can come this third image. It easily separable the ocean and land. So if you observe this ocean, small white patches, white dots, these are all boats. This is the point features, ships. So this is the point feature. So any satellite imagery, first so many features also appeared, but you should classify into three type of features. Round shaped is polygon, line shaped is line, and point objects is point feature. And contrast also very important. See, contrast means you have to improve the enhancement techniques on the image, then only you can easily separable the two objects on the image. These are the rules. Then there are two types of methods used for image processing. One is analog and digital image. What is the analog image? What is the digital image? See, here much interpretation and identification of targets in remote sensing imagery is performed manually, visually. So what here explained here, interpretation means, here interpretation means identification of the image. By visually you can identify the satellite image. That's called human interpreter. That is human interpreter. See, this is the human interpreter. In many cases, this is done using imagery displayed in a pictorial or photographic type format, independent of what type of sensor was used to collect the data and how the data were collected. In this case, we refer to the data as being in analog format. Here, if you observe here, analog format. Analog format means this is the photographic film only. Just whenever visually seeing the analog image, just you get the features on the image. You could not get much information from that analog image. For example, if you take any analog image from our college, whenever you see that analog image in the our college, you can observe one building, U-shaped building, and ground, some trees appeared like that only. We could not find out the how many trees are on the MLAG image, how many rooms, how many departments in MLAG image. We could not get that information. Just you can get the future, which future on the analog image. Why? Because this is the continuous image, not is descriptive. This is a continuous process. Analog image processing can be used for hard copies like printout and photographs. Analog image is nothing but some hard copy printout. Just you can see that you can identify this is the ground, this is the MVR building, this is trees. Just like that only it appear. Image analysts use various fundamental of interpretation while using these visual techniques. Visual means by using your human eye, you can observe the satellite image. What is the feature on the example? Analog image or television image, photographic, painting, medical image, like that only. So just you can, whenever you are seeing by using your human eye, this is MVR college building, this is ground, this is trees, this is the road, like that you can observe that. Otherwise you could not get much information, more information from the analog image. But in the case of coming to digital image, remote sensing images can also be represented in computer as area of pixels, which each pixel corresponds to a digital number representing the brightness level of the pixel in the image. In this case, the data are digital format. So A remote sensing image always represent the pixels, array of pixels. Each pixel is a number of it indicates the digital number. Each digital number represents the brightness value. Each brightness value gives the energy of that target, pixel number of the target. So I will show to you. If you observe this, left side is analog image, is a photographic film. Right side is digital image, is different. It's one kind of different. This is the grid pattern of detectors. If you see, this is the grid pattern of detectors. It is very sensitive to incoming light. It's very sensitive to incoming light. Just you can see it's looking like a chessboard. This is each detector makes up element of whole picture. Each detector gives the element of whole picture. Each detector is able to measure the amount of energy that is hitting. It is a measurement of numerical value. Each detector it gives the numerical value of that pixel. This is the difference between photographic film and digital image. Digital photographic film and digital image, we will get much information when compared to the analog image. See, same point they are explained here. Manual interpretation. Manual interpretation means one person seeing the satellite image. One person analyzes the satellite image by visual interpretation by using their human eye. That is manual interpretation. Manual interpretation is often limited to analyzing. Its analysis is very limited only. Not much information we could not get manual interpretation. So manual interpretation is often limited to analyzing only a single channel of data or single image at one time due to the difficulty to perform the visual interpretation with multiple images. So by manual interpretation we could not get the much information. Why? Because it is single data only one time you can get the single channel data, single image data. And we could not interpret it multiple images at one time. That is the drawback of manual interpretation. Manual interpretation also important to get the important to get information from that image, but we could not interpretation with multiple images at one time. Only single data, single image only. Second point, the computer environment. The computer environment is more amenable to handling complex images of several or many channels or from several dates. The computer environment is more amenable to handling complex images of several or many channels of or from several dates. So what here explaining, computer by base when compared to human interpretation, computer more it have handled more complex images at one time, several channels at one time. That's why it is better to analysis of digital imaging is better. In this session, in this scene, digital analysis is very useful for simultaneous analysis of many spectral bands, can process large data sets much faster than the human interpretation. What he explained here in this slide, when compared to the human interpretation, digital processing interpretation is very faster than the human interpretation. So at one time, multiple spectral bands we can easily analysis by digital image process techniques, not human interpretation. But human interpretation also, without visual interpretation we could not analysis anything. That's why, but human interpretation, when compared to human interpretation, digital imaging gives the much faster information, and it is continuous range of values representing position and intensity image is analog image. So I already explained to you continuous process, continuous range of values, not single value. It is continuously, it will gives the values in analog image by human interpreter. In many cases this is done using imagery displayed in a pictorial or photographic type of format, independent of what type of sensor we are used and how to collect the data. That is also it is it is independent of type of sensor. So it is not dependent upon which type of data are used, which type of sensor used. Just what is the feature or appeared on the satellite image by the analog image. In this case, we refer to the data as being analog format. This is the continuous range of values representing the position of intensity. But here pictorial representation only. That's why you could not get more information from the analog images. So much interpretation and identification of targets in remote sensing imagery is performed manually, visually. We have data in analog format, just it is appeared in the analog format. So digital imaging process techniques help in manipulation of the digital images by using computer. So digital imaging process techniques, it is very helpful for. So it is a discrete quantities. In the case of analog image, it is a continuous, but it is a discrete. And digital image, these three general phases that all type of data have to undergo while using digital techniques are: one is pre-processing, second one enhancement, third one display and information extraction. So three general phases here. So all the type of data have to undergo these digital techniques only. What are the techniques? One is pre-processing. What is pre-processing? Pre-processing means we are going to rectification, mosaicing and importing. These are all pre-processing. Before going to produce the satellite image, first you should apply these techniques to the raw data. What raw data, whenever you apply the pre-processing, then only the errors also removed from the raw data. That is pre-processing. Due to the pre-processing technique, so many errors we can easily remove from the due to the pre-processing techniques from the satellite imagery. Then enhancement. Enhancement means, so whenever you apply the enhancement technique, then noise also reduces, then sharpness also increases, brightness of the image also increases. So this is very suitable for displaying the image. After pre-processing, you should apply the enhancement technique. Due to the enhancement technique, the brightness of the image is very improved. The contrast also improved. Then display information extraction. Then only you can easily interpret the satellite image features. You can easily get the information from the satellite image. So this is the process of digital image techniques. So basically, what is a digital image? You know very well, contain finite number of elements, each of which has a pictorial particular location of value. So it contains finite number of elements, each of which has a particular location and value. So each element gives the location of the target and gives the digital value. These elements are called picture elements, image elements or pixels. What is the advantage of digital image? Fast processing, cost effective, effective storage, efficient transmission. How much data you want to store, you can easily store that data in the computer. Scope for versatile image manipulation. So these are all advantages of digital image. If you observe the difference between analog and digital image, if you see, left side is analog image. In analog image, this is the continuous process. That's why you can see the face is some blur. We could not get much information from that analog image. If you observe the digital image, see, this is the discrete values. Discrete values means pixel by pixel we will get the information. So pixel by pixel. So analog image is a photographic film, but digital image is different. Digital image is different. It is grid type of pattern. Each detector makes a element of whole picture. So each detector is able to measure the amount of energy. Each pixel is able to give the amount of energy that hitting the radiation. So you can easily measure the number of values, number of pixels. If you can easily change the pixel number, then you can easily change the contrast of that image. So the brightness also we can improve, the contrast also you can improve. Then much information we will get the, for example, we will get the digital image. For example, if you take any photo from the MVR college, so in analog image, what should you appear, what you can analysis from that image? U-shaped building, MVR building. In front of building, ground also appear, and on the ground some roads also appear, some trees also appear. Just you can, whenever you are seeing with your human eye, just this is the U-shaped building, this is all trees, this is the road network. But same area you can take, you can observe in, you can take the digital image and you can observe the features on the same area. You can easily analyze the features, U-shaped building, ground, trees and road network. Not only these features, so how many, if you observe inside the building, how many departments also there, how many rooms also appeared, how inside the rooms how many benches also appeared in digital image. Digital image gives the pixel by pixel information. That's why we can easily separate the features on the satellite image. Each feature, how many, what is the attribute of the satellite image, we can easily get the more information from the digital image. That's why in satellite image we can follow digital images. Satellite always gives the digital images and we can easily get more information from the Earth surface features on the satellite images. These are all difference between analog and digital images. Now, elements of visual interpretation. Till now what we are learned, what is the image analysis, how to do the image analysis in interpretation, which type of image also, or the analog image and digital image, what is the interpretation. So these are all introduction. Next, elements of visual interpretation. You know very well, interpretation is identifying the image by visually. Visual interpretation means first you have to identify the features on the satellite image. So you should follow some. So in visual interpretation, analysis of remote sensing imagery involves the identification of various targets in an image. Those targets may be environmental or artificial features. So many features also appeared, point, line or polygon features. So many features also appeared on the satellite image. May be environmental features or artificial features. In any target you can appear in the satellite image. So how to interpret the image? So So element of visual interpretation, all visual elements of we will explain: tone, shape, size, pattern, texture, shadow, and association. These elements I will explain one by one in my next video. Elements of visual interpretation is a second lecture in second video for second unit. Okay, you can watch my next class in second video of second unit. Thank you.